I'd like to talk to you a little bit today about the chain rule. Now, to be honest, the chain rule isn't truly a new rule like the other ones that we've presented. What you need to do at the end of every problem is let that key phrase that I've talked to you about in class ring in your minds. Take the derivative of what's inside, or times the derivative of what's inside. So let's look at our first example here. My function f of x equals the quantity 6x squared plus 4 to the fourth power. Now, when you do that, I want you to, for just a second, to kind of think of it. What if it was just an x? What if it was just 6 times x to the fourth? Well, you just take your simple power rule, right? You go the 4 times the 6, I will let you do that shortcut, is 24. And you subtract 1 from the power is 3. Piece of cake. Well, let's apply that back here to my basic rule again. I have something to the fourth power. Unfortunately, it is not just x to the fourth power. So what I need to do is I need to move the 4 down in front, subtract 1 from the power, and I'm done. Unfortunately, I'm not really done, because remember, you have to go times the derivative of what's inside. If this was a simple x to the fourth, like the example I just showed you, then I really would be done. But unfortunately, this entire quantity is raised to the fourth power. It's not just a simple x. So now I need to, once I've applied my basic power rule, take this times the derivative of what's inside. I need to consider what is the derivative of my 6x squared plus 4. Well, now I use the basic power rule again. 2 times 6 is 12. Subtract 1 from my power. 2 minus 1 is 1, which is understood here. So my derivative is simply 12x. So I'll basically just tack that right on the end. And from before, remember, I had my basic rule. I'm just tacking on that 12x. But here I've written it more neatly for you. So I brought the 4 down in front, subtracted 1 from the power, and then just tack on the derivative of what's inside. Now I'm going to simplify this a little bit, make it a little neater. I'm going to bring this 12x over in front with the 4 and simplify it, and I get my final answer. The derivative equals 48x times the quantity raised to the third power. Let's go ahead and take a look at the next example now. Let's talk about the natural log rule. Now, you guys know the natural log rule. If I give you a function, and it's the natural log of x, and you want to take the derivative of that, it's simply 1 over that x. Piece of cake, right? It's not really any harder here, but the function is a little more complicated. It's not just the natural log of x, it's this entire quantity again. So, once again, what I'm going to do, just like before with a natural log, when you take the derivative, you just take 1 over that thing. And I'm done, right? Not exactly. If it was just an x, of course, I would be done, but it's more complicated. So once again, I need to ask myself, what's the derivative of what's inside? What's the derivative of this x squared plus 5x? And plus 7, of course, but we all know the derivative of the 7 is 0 because there's no change. But again, the derivative of what's inside here, I've got to multiply it times this. So I take 1 over that quantity. The derivative of what's inside is a 2x plus 5. So I have to multiply times that. Now, to be honest, as far as the calculus is concerned, this is like the last problem. It's done. I'll give you half credit for just getting this far. But let's try to put it in the right form, shall we? I need to rewrite this as a fraction. Think of it as 2x plus 5 over 1. So this simply becomes 1 times 2x plus 5, or 2x plus 5, and x squared plus 5x plus 7 times 1, which is just our x squared plus 5x plus 7. And now I really do have my final answer in a more proper form. Let's take a look at one more basic one, if you will. Now, think about our e to the x. If you have e to the x, and I wish to take the derivative of that, it's simply e to the x. It's probably the simplest formula you'll ever see as far as taking derivatives, right? So let's look at this slightly more complicated one. It's e to the anything is the way I phrased it in class. And of course the derivative of e to the anything is that same e to the anything. And I'm done, right? And once again, I'm just saying that facetiously for effect. Of course I'm not done because this wasn't just an x. If it was, I am done. Since it's not, I have to take the times the derivative of what's inside. In other words, times the derivative of that, since it's not just an x. You've got to think what you've got instead of just an x, and you've got to take the derivative of that. I always phrase that as the derivative of what's inside, as if that was inside parentheses, which of course you could write that way, but I always use that phraseology. You need to realize what I'm really saying is times the derivative of what you have instead of x. So what you have instead of x here is a 5x squared. Well, the derivative of 5x squared is 10x. So I have to take the same thing I just had, basically, times 10x. And I'm going to make it a little prettier again. I'm just going to move the 10x out in front. And that's the way that I'd like to see it on the test. Okay, I've got one more for you. I tried to give you a complicated one here. Check this one out. F of x is the cube root of that ginormous quantity squared. Well, first of all, you can't even use your basic power rule, which we'd like to use here, correct? So I'm going to have to write this as a fractional power. And remember, we always take the power divided by the root. So I'll rewrite this in a more proper form. So I have my quantity to the 2/3 power. Let's go ahead and take the derivative. What would you do if this was simply, let's go off to the side here again, if this was simply x to the 2/3? You move the 2/3 down in front, and we have x, subtract 1 from the power, and we'd be done. So let's do that same thing here, right? I'll move the 2/3 down in front, and I subtract my 1 from the power. I've got negative 1/3, and we're done, right? And of course not again. Once again, just being facetious. This wasn't simply just an x. You need to take the derivative of what's inside. The derivative of this thing that you have that's more than just an x. Well, what is the derivative of this quantity? The derivative of that quantity would be 8x plus 5. So I go ahead and multiply times 8x plus 5. Now once again, it can be a lot prettier than this. We've got some issues here too. We've got negative powers. I've said numerous times in class I don't like negative powers in your final answer. And I've got this 1/3. I don't like fractional powers as well. I need you to put this back in the more proper, respectable form, if you will. So let's go ahead and look at this. First of all, my fraction, I've got a 2 on top and a 3 on top. And I'll go ahead and write these other things as fractions as well. This negative 1/3, you'll recall, really says that this is in the denominator. So I just simply move it to the bottom and make it a positive 1/3. And my 8x plus 5, frankly, I'll just go ahead and write like it's 8x plus 5 over 1. Now I have all three written as fractions, and basically in the numerator I have 2 times 1 times my 8x plus 5. Ran out of paper there, folks. There we go. So I've got my 2 times 1 times my 8x plus 5. And let's go ahead and just fix this denominator here as well. I've got this to the positive 1/3 power. Let's put that back in radical form. And I have the cube root of that quantity instead of to the 1/3 power. There, by the way, there's an understood 1 power here, but you needn't write it. So again, in the top I have 2 times 1 times 8x plus 5, which is just 2 times 1 is 2 times 8x plus 5. In the denominator I have 3 times 1 times this radical. Well, I'm just going to go ahead and write that as 3 times the radical. I'm almost done, folks. I'm being a little persnickety with you. Truthfully, if we were done and you wanted to leave this in factored form, I'd probably let you leave it this way. I prefer multiplying it out. At this point, that really is just a personal thing. I probably wouldn't take off again. I know I wouldn't, as a matter of fact, if you leave it completely factored. So this would be fine. But I just prefer multiplying it out and making it an 16x, plus 10. And now we truly are done. It's totally simplified. Frankly, it's in the proper form that I want it in, so you get full credit, obviously, for that answer.